So previous four classes, just summary as the first class was mainly basics of C, why we should see, we should use C, how C is very useful. The simple answer is C gives this perfect tool to interact with the hardware itself when compared to other programming languages. The only reason is it was one of the first programming languages written. Okay, and then what else did we do? We saw what binary and how binary addition, binary arithmetic works as such. Then you can start recording the session actually.
Yep, it's recording.
And then we saw we wrote our first C program that was print hello world, which is literally this one. We saw the various parts of a C program and why are they necessary and how are they useful in telling the computer what is to be done. The biggest thing I emphasized in the first class was it is okay to get errors. You don't have to panic as soon as you get errors. If you get an error, read the error. Usually, the computer tells you what exactly you made, what exactly was a mistake. So now I put backspace. Now there's no semicolon in this line. When I hit run, it's going to give me a semicolon error. So just read it. Error expected semicolon before return. It literally tells you what to do. Like in the previous sem, I saw a lot of people asking errors. I'm not saying it's wrong to ask. I'm just saying just read it once before coming. Like it's okay to get errors as such. Mm, then what else? Second class, we went through how what are format strings, how printf statements work, what is the default output device that is the monitor, and what is the default input device that is your keyboard. It's the keyboard, not the mouse. Keep that in mind. Um, on the second session, we went through something called as an if-else statement. Now let's assume we had to branch. If there is a yes, if a condition turns out to be true, then you have to do something. If the condition turns out to be false, you'll have to do something. In such cases, an if-else statement is very useful. And then we also saw the various operators. Yeah, I don't remember those. While that opens, we also went through something called as a control structure called as switch case. Switch case, when compared to if and else, is powerful when there are constant integral values which is returning as conditions. For example, it's mainly used in cases where the thing is a menu-driven system. So menu-driven system, if you want me to define it, it will be like um, enter. Let's say you're creating a calculator. Okay, so the menu will be addition, subtraction, multiplication, and division. And for each of those, you'll give a corresponding number, which will initiate or execute that set of statements. So, like in a switch case program, there'll be a switch, and you'll put n, and there'll be a case and an integral case and integral case and an integral. So now the basic condition is if n corresponds to any of these cases integrals, the lines below the case will be executed. So that will take a yeah, this is the one. So coming back to operators, we were talking about operators, right? So there are 1, 2, 4, 5, 6. There are supposed to be 8 operators. Okay, so fine. We'll go with 6 for now. Oh, okay, there are 2 more bitwise operators. Bitwise operators are something that comes under pointers, so I didn't take that from. So logical operators and or not. If two conditions are true on the either side, then in the whole condition expression returns true. If either of the condition is true, then it returns false. And then for in the case of one of the statements has to be true, that will return true, and not it will just
Aditya, are you there? Or is it my connection? Yep, you're audible. Yeah, we can see.
We just change networks.
I guess you can switch off your video then, maybe if that is the problem. Yeah, for those who joined just now, maybe you can open the editor which Aditya sent in the chat if you have access to it. I'll share it again and try to follow along.
Am I audible?
Yep, you are audible. So today we'll do some questions as well, right? Later.
Yeah, we'll do some questions as well.
Nice.
I don't know, when something with this T-shirt and the internet doesn't go well. Even in the first class way, when I had this, I was wearing the same T-shirt. Okay, moving on. Computers as such are dumb, and they just do whatever you tell them to do. So they follow something called as hierarchy of computers. To follow, so they are the set of rules which the computer follows to solve an expression as such. Now we use board mass, or some people may know it as PED mass, brackets of multiplication, division, addition, and subtraction. They use this hierarchy where the parenthesis gets resolved first from left to right, and then the arrays brackets. Like, let's say there's an array of length 10, then the a of 3, if that is in an expression, a of 3 first gets resolved. The value of a of 3 gets first substituted. Then the parenthesis, then the expression is continued. These are unary operators, not operators. So, like, if it is 0 or 1, it becomes, if it is 0, it becomes 1. If it is non-zero, it becomes 0. Minus minus, it's a unary decrement operator. So if I say a minus minus, it is equivalent to a minus 1. There is something called as pre-decrement operators. That is a peculiar case of unary operators, which is pretty useful in while writing programs. Plus plus just behaves like the increment operator. Slash, star, and percentage. Slash is the division. Like, if you're dividing two integers, you're going to get an integer only. If you're multiplying two integers, you'll get an integer only. So you can't expect 5 by 2. 5 is an integer, 2 is an integer. 5 by 2 to return 2.5 in C. If you have given 5 as a float type value, 5.0 by 2.0 only can you expect to get as 2.5. So keep that in mind. And then percentage is finding the remainder of two values. So 10 percentage 2 is 0, 5 percentage 2 is 1, because quotient is 2 and remainder is 1. Then addition and subtraction. Pretty straightforward. Relational operators as such are these. So greater than, lesser than, okay. Those are there. Then we have and. These are the logical operators. This is something called the ternary operator. I didn't even take this. We'll do it later. That's not an issue. And then assignment operators. These are assignment operators. Okay. So I'll show a few of them so that we'll have a bit of idea. I'll explain a few things as I'm going on. Okay. As I told you before, computers are dumb, so we'll have to tell it everything. So int a is, I'm declaring a as an integer variable. So yeah, a can hold the only value of only hold integer values and not any other values. Now I'm going to say like a plus equal to 3. hit tab. I'm going to do printf HD, and I'm going to say A. Now, what I expect it to do is uh, I'm expecting it to do something like A equal to A plus 3. But then I have not given any value to A. So let's say A is 5. Now, effectively, the answer should be 8. So let's see what happens. Yeah. Yeah. So the answer is 8, and we are happy with it. That's the same for other values also. So when you do something like this, what exactly happens is you're saying A equal to A plus 8. The only use of such an operator is makes the code look cleaner and it is easily readable. So like, yeah, that's pretty much it. And then we had data types. Data types, they are something that is to be kept in mind. At the same time, it's not that important as long as unless and until you are making full-fledged programs. Maybe for a project, we'll have to keep all this in mind. But for now, just to understand the syntax, it should be pretty straightforward. I'm so sorry that I can keep these open. Uh, just a minute, guys. So I'm so sorry about this.
This actually happened during our evaluation. We had to make her wait for like 10 minutes during our logarithm evaluation. During the presentation, you remember? Wait, so what are you planning to tell through the PPT right now?
Yeah, the data types. I had to run
Oh,
them uh, because that was something I had to spend a considerable amount of time in the first class itself. Yeah, yeah. Let us go. I think I did this already. No. Yeah, there you go. Fine. So, one byte is 8 bits. One bit is either a 0 or a 1. Okay, keep that in mind. So a character takes 1 byte of space. An integer takes 4 bytes of space. 2 is pretty much outdated because all our systems are 32-bit systems. So 4 is the norm. Like if you're declaring an integer, it's going to reserve 4 bits of 4 bytes of space. That is 32 bits. So it requires 32 zeros and ones to make the maximum range over here. Sorry, the maximum range over here. That is 2,147,000,000 something. It requires 32 zeros and ones. And then we have something called an unsigned list. The difference between these two is we'll just get an extra range in the positive direction because the negative is completely ignored, right? And then we have short int. It only takes 2 bytes of space and that's the same operation. Unsigned short is the same. It just doubles the range. Long int are used in applications which involves banking, accounting software, so, where there are a lot of literally big money flowing. Unsigned long, it just doubles the range because there is no need of the negative side, right? Then we have float. 4 bytes, 32 bits. This is 1.2 into 10 power minus 38. Oh, sorry. Oh, yeah. So literally 6 decimal places, 15 decimal places, and 19 decimal places as such. I hope this is pretty much the summarized version of it. Okay, moving on. Format strings. Format strings are, sorry, not format strings, placeholders. Percentage D is an example of a placeholder. Computers are dumb as such, and you will have to tell it to do everything. So when I say printf, in brackets, I say percentage D. I'm telling the computer that I'm printing an integer value over here. Now let's say A was a character. Okay, A was a character containing 53. Now 53 doesn't have the value. The character data type 53 doesn't have the value as an integer type data type in integer type 53. You can't add one to character type 53. It literally doesn't work. And then what did we do? Yeah, and then yeah, that's pretty much it. So is it clear till now? Any doubts?
No, yeah, I was there in the previous session,
Yeah.
so yeah, I guess it is clear. It was not very difficult.
Our control structures written to, used to do the same thing multiple times. So there are three types of loops in C. For, like two types of loops, but then three control structures: for, while, and do while. For and while are test loops. So before entering the loop itself,
Basically, it's exactly like logarithm, only the syntax we are using is different.
yeah, exactly, yeah, pretty much. Um, so yeah,
I
for
guess you can start with some basic programs and using those programs tell them.
okay, great. So we'll start with the if statement. So I want to check if my if age is sorry, if I'm eligible to vote or not. Okay, so I'm saying in age semicolon. I'm going to use a command called scanf. What the scanf does is it picks allows the user to input from the. Uh, then I'm going to give ampersand a. Here, a refers to the value stored in a. Ampersand a refers to the address where the value is stored in. So that's exactly how it. That's exactly why you have to give ampersand a. The only reason is it is coming from an outside source, that is your keyboard, and not an internally computed value. Okay, I'm going to say if uh, a is greater than 18, open the curly braces. That is called a control block. Inside the curly braces, any statement that is there will be executed if the if statement turns out to be true. Now I'm going to say printf. You are eligible. Where a semicolon is not required because I have a control block open here. Okay. And I'm going to say else. Uh, return 0. Plus, this main function returns an empty variable. Okay. If there is only one statement, there is no requirement of these control blocks. These curly braces. But then it is a best practice to put them wherever you use it because it makes it easier to read the code. So now if I run this, I should be allowed to say 12. I'm not eligible. Okay. Yeah. I should say greater than or equal to. Then we have one. Pretty much. This is the syntax. Just keep the syntax in mind. Then we'll do something with for loop. Now I want to print the first n natural numbers. Okay, so is equal to 1. Then I should be lesser than or equal to 8. Then I'm going to give another semicolon. And I'm going to say I plus plus. This is the place where the plus plus operators become very useful. So I'm going to say I'm going to open a control block. I'm going to say printf. Something called as backslash. Backslash n is a escape sequence for a new line. I'm going to do okay.
The for loop is, I think, wrong. You put one there.
No, that's not an issue. Read the error. I did not declare I. So just read the error. It usually tells you what to do. Okay, so, oh,
Yeah, that's what I was telling. The for condition, the middle condition, check it out.
yeah, these are all logical errors. Like, yeah, I was telling the other day, right? Logical errors are errors where the program is actually perfect, but then logically it breaks down. Right? So, from 1, 2, 3, 4, 5, 6, 7, 8. Now we'll try the same program with a while loop. Quick enough. And now I is not going to be say automatically incremented. So you have to give an increment. Ah, I did not declare I should be initialized. Ah, I did not give semicolon. Yeah, I know. Okay. So while writing a while loop, initialization has to be kept in mind, and the implementation also has to be kept in mind. Now let's write a do while loop first. For do while, the syntax is slightly different. You put it over here, come to the end, and put give a while, and in brackets we give the condition. Okay. Then you give a semicolon in this case. That's because that's the end of execution, right? You want it to come out after if this thing turns out to be false. So let's see if everything's correct. Open this. Uh, so any doubts as such? Like you get an idea of how the syntaxes are, right?
Yeah,
Yeah,
I guess
yeah. It's easy. It's easy. The
yeah, we can
The
try out
first
some
I
problem.
want you to write is let's say there is you have to input two numbers, which will be the base and the exponent. So I want you to compute 2 power 5 or 2 power 10 using loops. I don't want you to use the inbuilt function. I want you to compute it using loops.
Yeah, cool. We'll try.
Yeah, go on.
Um, and yeah, is everyone able to access the uh, ID? If you have any problems, you can just tell us. We will help you. Maybe you
So,
can explain the problem to Sandeep. He just joined.
Sandeep,
Yeah, bro.
so the question is, you'll have to write a program to compute the powers of a number. So and you'll have to accept two numbers, which will be one will be the base and the other will be the exponent. And you'll have to write a program using loops to find 2 power 5, 10 power 20, things like that. So that's the first question. So
Have to
write,
find the power of the numbers, right?
yeah, find the power of after accepting the base and the exponent.
Okay, actually, I have to think,
Yeah, take your time. No issues. 10 minutes.
but I can't share bro, because I actually joined through my mobile because uh, okay, bro, I will try to share it.
Take. I mean, like it's possible do, but then try doing the program. Someone joined, saw my face, left. Okay. So about 10 minutes, then I'll do the program. That's not an issue. Okay. But I'll be right here. You can ask doubts anytime.
And Aditya, I,
Yeah, I'm there. I'm there.
this is how you take two inputs, right? I forgot. Like, if you want to take two inputs separated by a space, this is how, right? Or,
Percentage D.
or should I? Is this right?
Yeah, it is right, but then it's percentage D, not percentage I.
But it'll give the same output. I tried it.
That depends on the compiler. Best practice is to get percentage D.
Okay.
That's uniform everywhere. Okay, wait, I'll send the book. Okay. That book is literally a holy grail for all syntax related arguments in C. Okay. So, I've sent the link in the chat box for the book. Chantrita, were you there when I told the question?
Um, I'm not there at that time.
Okay. Okay. The question is, you'll have to write a program to find uh, the exponent of a number where you input the base as well as the exponent. So input both 2 and 5 and find 2 power 5. Input 3 and 5 and find 3 power 5. So you have
Okay,
to,
I will try.
yeah, yeah, yeah. Sure.
Yeah, I'm done.
Does it work?
Yes.
Even if the power is 0?
Let me know.
Yeah, then do something about it.
Yeah, cool. Oh yeah, it does work when it's power 0. I didn't check it. Oh wait, never mind, it doesn't work. Yep. Now it works again for 0. And is it till 7:50 or 8 today?
Can do till 8 if you want.
Cool. I'm free.
Do you want me to write the program, or can we just share Arjit's screen and get it done?
You want me to share the screen?
No, I'm asking others, not you.
Oh. Yeah, you can feel free to use the message and the chat option too if you're too
Yeah,
shy.
like too shy to speak.
I mean, you don't need to be shy to speak because just
You can
saying
share. Basically, you can share. Let's see your program. You know.
Oh, okay. You want to see my program? Yeah, this I added after you told. So, do you want me to explain? So, I inputted two numbers from the user. One is the base, and the other is the exponent. Then I put the base in a different variable so that I can keep multiplying it here without changing the value. Yeah, so basically that's it. I kept multiplying k with the base n times to find the value of the exponent. The exponent, yeah. It works.
Yeah, but then this if-else statement is absolutely unnecessary. We can't do it without the if-else statement.
Yeah, even if it is 0.
Yeah.
Okay.
Okay, fine. Your solution is absolutely correct. Okay. Like there's nothing wrong about the solution, but then you have to make it efficient. So we say in base and I'm going to int and I. I'm going to say f is equal to 1. So for I, we can do something. Okay, I'm not sure if this will work. Okay, so I can say while x greater than 0, f star equal to base. Okay, and then I'm going to say exponent minus minus. Now I don't even need I. I'm going to say f Steve and what is it? F. But I have to accept. Okay, now I'll tell you what happens. Now I've declared that f initialized that f is 1. Now if x is equal to 0, okay, so this condition will turn out to be false. So it's going to come out of the loop and I'm going to print f anyway. So I'm going to print 1 anyway. Now if I say, we'll run this. So I'm going to say 2 power 2. Let's keep it simple. We're going to get 4. N power 45. Okay, maybe it took too long to say.
Yeah, so you're lowering the exponent itself rather than.
Yeah, exactly.
Okay.
So 12 power 2 is 144.
But Aditya, like you said before, since we know the number of times the loop is getting executed, so isn't for better?
Well, but then in that, yeah, it is better. In theory, it is better. But then, let's say, in practice, this is better. You're using one less variable.
Even using for, you can just use exponent and then subtract it. Use exponent as the recursive variable.
Yeah, you can use it.
Yeah.
But then I think in one of the sessions, you argued that while was better than for.
Yeah.
Yeah.
Yeah, I'll tell the reason later. I still haven't checked it.
So when when you have conditions like this, okay, it's better. You're not counting anything. Yeah, let's put it that way. I felt while was better while doing this, so I put while. That's like. So R0 is 1. Okay. Yeah. So any doubts in this program?
I don't think so.
Okay. Great. So can ask me if there are any doubts because question for me was first year. We'll do one more program and then we'll close. So what I wanted to do is, did we do the prime number thingy before? Find the prime numbers.
You gave it as homework.
Yeah, and did you?
I solved one of the questions. I didn't try. I was too lazy.
Okay, we'll do the Armstrong number. Okay, so let me explain. No, Armstrong number will be too long. Okay, we'll do prime number itself.
Fine.
So if I give a number 43, it should the program should tell me if it's prime or not. So that will be the last program. Like when you guys type the thingy, I'll also type over here. My screen unshared, of course. So in 10 minutes, we'll see again. Okay.
Okay.
So the statement is basically if I say 43, so tell me if it's prime or not.
Yeah. I did almost the same thing.
Okay, so
I forgot to use a break though.
you forget to use break or forgot what was break?
Use. Because I tried it only for small numbers, so anyway it wasn't very useful. So I didn't get an error till now. So
Then that's
not-
fine.
okay.
This will be
Don't you think using the flag thingy is kind of complicated? Why don't you just print it then and there instead of using the flag?
it doesn't work for two. I don't know why it doesn't work for two. I have to look into it.
You can put an exception for 2.
No. You try to include all cases within the same program. That is fine. Good. So this is the RAM. You can start recording.
Okay, cool.